This video I want to do a limiting reactant problem with the table. So our concept is limiting reactant. We're going to use the same reaction I used in the other video, the thermite reaction. So again, we start the molecular weight. We write the molecular weight for each reagent above it. So we've already figured these out previously, so I'm just writing them down. This one is 55.85 and the last one 101.96. Now this is the molar mass, so this is the mass of 1 mole, mass of 1 mole, mass of 1 mole, and mass of 1 mole. This time, to make it limiting reactant, I have to give you amounts for iron 3 oxide. I'm giving you 125 grams, and we're going to do 55.0 grams for aluminum. So I know it's limiting reactant because I gave you amounts for more than one reactant. So I have to decide, is this in excess or is this in excess? So to do that using the table method, again, this is my given row, and this is mass because I was given mass. I wasn't given any of these. You can put 0 or just leave them blank. So we wrote our given. Started with balanced equation, got molar masses, wrote our given. So in this case, I'm going to start with iron 3 oxide, and we're going to assume that iron 3 oxide is limiting. We don't know if it is, we're just assuming it is. So I'm going to change grams into moles by taking the mass and dividing by the molar mass, and that gives me 0.7827. Sorry, it looks terrible. Moles. Remember, this is our mole row. I don't do anything with the aluminum. I'm assuming this is limiting. So I take the mole amount of my limiting and I get mole amounts for all of my other substances in the balanced equation through mole ratios. So I take the moles of iron 3 oxide, multiply by 2, divide by 1. So essentially multiply this by 2 to get the moles of aluminum. Not from 55 grams. But if all of this is used, how much aluminum would be required? So when I take this number and multiply by 2, I get 1.565 moles. This is in a 1-to-1 mole ratio with aluminum oxide. So if I have this many moles of iron 3 oxide, I have that same number of moles of aluminum oxide. Aluminum and iron are in a 1-to-1 mole ratio, so if I use this many moles of aluminum, I produce that many moles of iron. So generating the rest of the table is simply using mole ratios. Well, that's assuming iron 3 oxide is limiting. I have to also check and see if my aluminum is limiting. So my next mole row is to assume aluminum is limiting. Still we're in moles. Running out of room. So here I take my 55 grams and divide by the molar mass. And when I take 55 divided by the molar mass to get moles, I end up with 2.039. Again, I get moles of everything else in the balanced equation based on these mole ratios. So aluminum and iron are in 1-to-1, so I know I've got the same molar amount of iron produced as I used aluminum. But I have a half as much iron required to use that. So this mole amount divided by 2 is 1.020. They're in a 1-to-1 mole ratio, so 1.020, and that's a 0. So to decide what's limiting, I look at the amount of product, and it doesn't matter if I look at iron or I look at aluminum oxide, either one. But the limiting will come from the smaller amount of product produced. So this is definitely my limiting, because this product amount is less than that one. So this is my limiting. So this is basically nonsense. So when you're doing it, you can simply do a strike through that row, because you will not need it. It assumed aluminum was limiting, but we know it is not. So I know now iron 3 oxide is limiting. So I can already answer that question if asked. So I've got moles, so we need to go back to mass. And this will be the mass that reacted or formed. So since this was limiting, I already know the mass of this many moles. It's 125, so I'm just bringing that down. This is not 55 because this was in excess. As soon as I decide this is limiting, this is in excess. So I have to actually do conversions from moles to grams for the rest of these. So I take moles times molar mass to get the grams of aluminum, and we get 42.2 grams of aluminum reacted. Remember, this is my react or form. Reactants react, products are formed. Take the mole amount of iron times its molar mass, and that gives me 87.4 grams. And for aluminum oxide, moles times its molar mass gives me 79.8. So what do you have at the end after everything is complete? I started with 125 grams. I used 125 grams. React 0 is left over. I started with 55. I reacted 42.2 grams. I consumed those. So what you have at the start minus what's consumed leaves in excess 12.8 grams. Didn't have any, produced 87.4. Didn't have any, produced 79.8. So I can answer multiple questions at this point. All of my calculations are done. So if they ask you for the mass of the excess reagent, I already have it. There's 12.8 grams of aluminum in excess. If they ask me for the amount of iron formed, I have it. I would just say 87.4 grams of iron produced. If they wanted moles of iron, I already have it. Here are the moles of iron. I just need to round to the correct sig figs. And then if they ask for mass of aluminum oxide, it's 79.8 grams. Or if they ask me for moles, I have my answer here. You have to base all of your calculations on the limiting. So in a limiting reactant, we first have to figure out which one produces the least amount of product, and then star that row. That's the row you want to pay attention to, because these are the actual amounts that were reacted and produced in this equation.